Good afternoon, everyone. Welcome back. I'm Ilana Koegelenberg, the Market Intelligence Manager and co-founder of Atmosphere, and I'm joined today by Professor Michael Carfaldt of the Institute of Refrigeration, Air Conditioning and Environmental Engineering at Karlsruhe, University of Applied Sciences. I'll go into his CV a bit more detail later, but yeah, today we're going to be, let me get the presentation always ready. Step one. We're going to be talking about natural refrigerant applications and practical guidelines, the textbook that we recently published with German publisher VDE. And I'm very excited. It's been a long time coming. Just a matter of housekeeping. If you have any questions, there's a little Q&A box there at the bottom of your screen. You need to be actually logged into the event to send questions. I'll take them at the end of the session. And also, if you actually want to ask the question yourself, you can just, raise your hand and then I'll give the mic over to you. And you can also publicly speak it yourself. So yeah, let's get into it. I mean, this is a very exciting project for us. The book was published February 2022. It was translated from the German original. And yeah, I've actually received my own copies in the post recently, which was amazing. It's probably because I'm back in Brussels. I wouldn't trust the South African Postal Service. And I must say, I was very proud to see it all come together after so much hard work. It really looks professional. It looks great. It's good content, great quality, good stable of authors. This is exactly what our industry needs to address the training hurdle, holding back the wide adoption of natural refrigerants globally. And this book was, edited by Michael Kauffeld, Michael Eckert, and Volker Salesman. And our all-star cast of authors included Kauffeld writing quite a few chapters on some of physical properties, ice slurry, and air cycle technology, while Professor Armin Hafner did CO2, Michael Eckert did ammonia, Joachim Schatt and Nina Schulz did hydrocarbons, and Jürgen Florian and Karlsruhe as well wrote on water's refrigerant. So as you can see, a all-star cast, really, of very knowledgeable people. So let me get to the next one. This was my favorite part. It was actually, I skipped a few slides, the very important slide. Also wanted to just thank our advertisers really for your support. It's quite a few names out here, some really good, strong brands in the natural refrigerant industry, and thank you for your support and patience in making this happen. And then, this is, like I said, my favorite slide was watching people actually get their copies and having it arrive and seeing it being shared on social media. This was really cool. I think Michael will also share a few more photos of his own later in his side. But if you get your copy, let us know as well what you think. So let me actually introduce Michael with his not very short CV. I'll skip through the things and then just so you can see as well. And then we're going to try the magic of sharing control of the presentation. I mean, Michael's been in the industry, dare I say, longer than I've been alive. And you've covered everything from air cycle technology already in 1986, which was, I think, long before most people even thought of natural refrigerants. Worked at DTI, like Danfoss, Advancer now, even a whole host of IIR committees, even president of some work groups. It's quite an impressive CV. So definitely the right person to be talking to us about natural refrigerants. So that's, Michael, should we see if we can do the handover of the remote control in this very modern world? Let's see, magic. Just need to unmute yourself and put your mic on, and then we're good to go. Just a second.
And also video if you can. So people can see how I look right now. Well, you can also keep this picture on. It's also nice. Was on my sailing boat 2 years ago when I spent the 6 months research at Advancer. I think I spent as much time on the sailboat as I spent in the office.
Well, let's see if we can see you. There you go.
Yeah.
You've got voice and video.
Yeah.
Now let's see if we can get you control.
Yeah, let's see. Should somehow work.
Yeah, there you go. You're all set.
Okay. I actually started studying mechanical engineering at the University of Hanover in 1983, and then my thermodynamics lecture by Professor Baer, who wrote the most famous German thermodynamics textbook. He said, study whatever you want in mechanical engineering, but not refrigeration technology at Professor Kruse, because the only thing they come up with every year is a new design for the air compartment. That was in my, I think, second or third semester. I don't know, this with the control is quite slow, I guess, if it's working at all. Yep. But I didn't attend the thermodynamics lecture anyhow, because I didn't know back then that Professor Baer was so famous, and I didn't think about going into this industry, because I wanted to be a design engineer, until I found out that everyone was sitting in front of a computer in a dark room looking at very thin lines. And then I said, no, this is not me. And then luckily there was the option to going to the US for students studying refrigeration engineering. So from one day to another, I changed the subject and spent. This is too slow. I think it's almost faster if I give you the control, Ilana, and then I just say next slide or next.
Okay, let's try it that way. But like that, let's see if we can make it work.
Okay, and then I went to a National Bureau of Standards in 1986 in August, and took some classes at Catholic University in Washington, D.C. And I remember one of the first design projects, a homework project, was on a cold store. And the rest of the class designed the cold store with R22, and I designed it with ammonia. And then the comment from the professor was, oh, well done, probably the nicest elaboration of the project, but I don't like the choice of your refrigerant. And then this small print, a masterpiece of German engineering. That was the slogan, commercial slogan of Audi back then. This actually was a masterpiece of German engineering. It's still in the museum of NIST today. And this was only possible because I joined the Navy prior to studying. So this American professor, he thought, okay, if this guy has sailed all around Europe for 15 months, then he can probably survive in the US as well. So next slide. So when I came back, then I joined Professor Kruse, and I had a very nice, yes, thank you, a very nice encounter with Professor Baer. He came actually up to me and asked me about the ozone depletion in the ozone hole, because I had studied that in quite some detail in 1988, 89. So that was something he didn't tell us in the thermodynamics lecture. And then this is solved thanks to the Montreal Protocol, but throughout my work in the Montreal Protocol, like I have been advising the governments of Uruguay, Jamaica, and Syria in 1998. And back then we already said there's a lack of training material, especially for natural refrigerants. So next slide. So nowadays, I mean, at least in the industrialized countries, the CFC ozone challenge is solved, but global warming is still on. And this is a fun picture, but the not so fun part is what you see on the right. Because despite, in contrast to the ozone hole, which was first on the southern hemisphere, because there the temperatures in the stratosphere are right for destroying the ozone. With global warming, we will see the highest increase in temperature on the northern hemisphere, because that's where we have all the land mass. And then on the southern hemisphere, so where you are from, Ilana, the temperature will not rise as much. So next slide, please.
That's good. It's already quite hot there. So.
Yeah, that's right. So this is has been my driving force throughout the last 36 years working in this industry. There is no plan B, so we should take care of the one we have. And then, yes, the next one you already mentioned, that was my PhD project, air cycle. Back then, we wanted it as a replacement for R12, CFC 12 in car air conditioners. But I found out that the COP is quite low for air conditioning applications. So I suggested in my thesis, use it for any temperature below -70, which you can actually buy today. And this is also in our book, a description of this air cycle technology for freezing, and became quite popular now during this COVID-19 thing with the first vaccines requiring -70 degrees. Okay, next slide. So when I was done with my PhD, at the same time I met my girlfriend. She was from Denmark, wanted to go back to Denmark, and then I joined Hydroaluminum. I was part of two developments at that time. One was these microchannel or mini-channel profiles, which were introduced in car air conditioning systems in the early 1990s. And also, I was also on this R744 CO2 team from Hydro, because Hydro was the one promoting or trying to sell the patent from Gustav Lorentzen from NTNU back then. We tried to work with the international car industry, but the ideas Hydro had about the royalty was not working with the car industry back then. So we never, during the 2 years I joined Hydro, we never made it into a real prototype. This picture is from later from a conference where the German Environmental Protection Agency built a prototype. And next slide, please. After those 2 years, I knew how to speak Danish, and then I moved on to Danish Technological Institute. And the first project was replacement of CFCs in supermarket systems. And we came up with this design in 1995, actually at the end of 94. So we said that should be the central ammonia plant or propane plant producing some ice slurry. And then the ice slurry can be used as thermal storage. And it can be used in all the medium temperature display cases. And then for the low temperature display cases and low temperature rooms, we would have decentralized CO2 systems. So this idea was created in 1994-95, and it took 20 years until the realization, as you can see on the next slide. We actually built a system like that in Karlsruhe, KIT, Karlsruhe Institute of Technology, which is the other university in Karlsruhe. This is supplying refrigeration for all the display cabinets in the central cafeteria. There are 90 display cabinets, and you see the ice storage, 40 cubic meter ice storage located outdoor, and also the refrigeration system is outdoor. There are some windows so that the students can look inside and see how those propane systems work. There are 3 systems with 10 kilogram each. So this was 20 years from idea to realization, which is not long if you think about the 100 years it took for electric cars, or the 500 years it took from Leonardo da Vinci's sketch of a man flying until we could fly with hang gliders. Yeah, and then if you click 2 times, you get some benefits of ice slurry. So the storage will be smaller, and the pipes are much smaller. So that's the benefit, and also the energy consumption is much lower than with conventional secondary refrigerants. Next slide, please. Yep. So this has been my vocation for the last 36 years. You see to the right a picture where I actually designed in 1995 the logo for that conference. That was the second IRR conference on natural refrigerants. And I said CFCs and HCFCs will disappear, and HFCs will disappear as well. And that was, we placed this as a poster in the 1995 International Congress of Refrigeration in The Hague. And people from American companies, they tore down the posters because they didn't like this logo, where we said that natural refrigerants will be the way into the future and will skyrocket the refrigeration industry. And then, as Ilana said, this book, Natural Refrigerants, just appeared in an English version. Ilana, you made an interview with me on the German book almost 2 years ago.
It was longer. I published, I looked back, I did that article in December 2019, and that's when we actually started the conversation. I can't believe it actually exists today.
And I was stupid enough to suggest that we should make an English translation. And
it's a good idea.
That that I like natural refrigerants, as the blue car was my previous car and the red one is the one I have now. So that was Germany R744 and Germany R718, which
There
is
can be no confusion about what you stand for. I'm impressed by that poster. I can't believe you've been saying that for so long, and some people are only realizing that now, that we need to move away from these refrigerants.
Some things take time to get into the heads of people.
Yeah. Oh, I love these photos. Please tell us what's happening here.
Yeah, the picture to the right is a friend of mine. He has this air cycle refrigeration climate chamber. It's like a medical chamber where you go in and are treated at -100, -110. And because there's no place on Earth where the temperature is that low, our DNA doesn't know what to do at that low temperature. So you go in naked, and then your body is reacting strange, and you get rid of any pain you may have in your back or in your joints, and you get rid of any like light psychological issues. It's really fun to be in there. You don't stay longer than 3 minutes, because after that you will freeze.
Is this why some people always jump into the ice and you see all those weird, strange?
Yeah, but that temperature is not low enough. So you have to go as low as this minus 90, -100, because then the body doesn't know how to react, and strange things happen. But good things.
Like a reset for your body.
Yeah. And then to the left is a picture of actually Johannes Reichelt. He was the professor at our university before me. And he is still alive. Of course, retired since 2004. And he just built a new house. And you see the opening for his heat pump system in the wall behind us. And as we dedicated the German book to him on the occasion of his 80th birthday, I also brought him the English version, and wrote a little text for him in the book. This picture was taken, I think, 2 weeks ago. Yeah. So, then let's look at the book. So we cover all the refrigerants, all natural refrigerants which you can think of, even some which are not listed here, like dinitrous oxide for very low temperatures. But CO2, of course, is in there and all the applications are described as for heat pumps and for commercial applications for low temperature industrial refrigeration and so on. We have a chapter on ammonia, which is mainly used in industrial refrigeration, but also in high temperature heat pumps nowadays. Then hydrocarbons are excellent refrigerants. We typically achieve 10 to 15% better efficiency than with HFCs. And HFOs are flammable, so are hydrocarbons, but the hydrocarbons have the advantage that you don't get nasty combustion fumes when you burn them. And then water as refrigerant is, of course, also a chapter, because this is very good. There's a heat pump actually in Aarhus at the harbor, taking the heat from the water in the harbor and transferring it to the local district heating plant. And then the air cycle, there's a chapter on air cycle or on low temperature applications, which I wrote, where we described this, for example, this freezing chamber for -100, where we took the picture together with Thomas.
Air cycle, really where your career started.
That's and there's an ad for propane. I mean, it was propagated as the odorless safety refrigerant 100 years ago, because it's not poisonous. So, but right now there's some nasty things going on, because of course you cannot really test it on humans, because if people breathe propane and there's a spark, then you will explode your test person. So not a lot of people volunteer to make tests when they breathe propane. But I mean, the young people, they're sniffing it, so they could actually measure on those. So there are not that many publications on what propane and butane and so on does to our body when we inhale it. And some people from the HFO industry, they try to misuse this now and say, okay, if there are no measurements, then it's probably unsafe to use those as refrigerant. So it's something where we have to, a new area where we have to fight.
It's been a bit scary, all the misinformation that comes out and the interpretation of data and kind of the misconstruing really of like studies. what's not being said. So I definitely think that's why the education is so important, and like actually training people to use these things safely. So otherwise we'll never progress. So I think a bit more, just to show how comprehensive this book is. This chapter is more than 100 pages. I think we're just like a bit of detail. I don't think we have to go into all of it, just to kind of show the type of what's covered in the book.
And ammonia is like, I think it's the best refrigerant. It achieves the highest efficiency, and everyone has a built-in leak detector in our nose. And there are two examples from Denmark. Those systems were installed in 1995, and they're still running. Actually, we had the conference in 1996 in this conference center, the picture to the bottom right.
Oh, wow.
And that is air conditioned with an ammonia system. And the ammonia system is located inside the building. So no problem there.
I mean, it's been around for so long. I don't know why people are still arguing about ammonia. It's just got such amazing efficiencies as well.
They even use it at the International Space Station because the heat transfer properties are so good. Yeah. So next slide will be on the CO2 chapter.
Yeah, a very in-depth chapter as well. Like you said, everything from heat pumps to how, and I think that's why I like this textbook as well. It's not really just speaking about things in general. It's like a practical textbook, like an actual textbook. There's diagrams, there's how to use it, and it's a very useful resource. I think here's a
this slide. I think is just a picture from the book from one of the diagrams. Armin Hafner wrote that chapter, originally it was a Norwegian publication by Hans Haukers, and then Armin translated it into English and added a few more up-to-date things. So and some applications also. Like in all the chapters, we describe some applications, some really live applications.
Yeah, it's really for the entire range of people, from the people designing it to maintaining it. It's such a good base knowledge to have. Same as hydrocarbons, also very in-depth, everything from leak detection to...
and there I'm very glad that we rewrote the hydrocarbons chapter, because in the German book, it's mainly just on the safety regulations and on standards. But now in the English version, it's similar to the other chapters where we describe the thermodynamics and how you design the systems and how you run the systems. And there's some applications described. So the English book actually has better information than the German one.
As I say,
Bernd just started the second edition of the German version. So we will for all the chapters take the English one as the starting point and then translate it back into German.
I was just going to say, I was speaking to the publisher this week, and you're already looking at doing the second German one. It's I mean, that's also a very good point. The English one wasn't just a direct translation from the German book. It was updated, first of all, globally as we went, but also to make it, to improve the information.
Yeah,
so
that's what we did.
Yeah, it was a journey and a half.
Here you can see the benefits of the hydrocarbons. I mean, hydrocarbons are better refrigerants than the HFCs, and you can see the market development. It's just at the beginning. I mean, if you look at the product life cycle curve of any new product, then this is just the beginning. There will be lots of hydrocarbon systems in the future.
I mean, that's phenomenal growth. I think this was a slide shared by Joachim during Atmosphere Europe, and just to show the growth of that exponential, it's a lot of demand for this.
I mean, hydrocarbons are completely safe or considered safe for barbecuing. So as Charlie Huber always says, propane, it's easy to grill but hard to chill. It's not accepted in the refrigeration industry yet by everyone, but I'm sure it will. But
on the heating and the air conditioning side, it just shows so much potential. Like it really, in terms of just even switching things over quite quickly. I think we're just getting a lot of pushback from the chemical side for obvious reasons.
Yeah, of course. Yeah, because the price is so low for the natural
thing. I mean, that's natural refrigerants. You can't patent it, right? That's why the pricing is so much lower. So I guess it's in people's interest to protect their income. We need to protect the environment as well.
Yeah, this is like the last slide I have. I always show this to my students. Like they have to invent new things, high product quality and inherent safety and high energy efficiency. That's very important. And they need to be creative, but they also need to have the courage to implement those new ideas. And there's this one idea, like the reversed microwave oven. Right now, you can see all the molecules in your food moving, and as you switch on your microwave, they move faster, and then the temperature will rise. And then if you click a button, we could make it freeze with all the molecules. If you click once more, Ilana, then the molecules will stop.
Yeah, I've clicked too far.
And that's by definition 0 Kelvin. So this will be instant freezing if someone invents this reverse microwave oven.
Aha, okay.
So this will revolutionize the refrigeration industry.
Is that an idea that's already existing?
I mean, they are doing it on an atom by atom basis in places like CERN or other, like where they look at the particles. But would be nice to see it later.
I'm sure you must see so many ideas come through the university, but I guess, like you said, the ideas you had took 20 years to come to fruition. So some of these things just take time.
And I try to inspire my students to come up with inventions. So there are quite a few students who have filed inventions when they were in my classes, and then we try to create research projects around them. And sometimes it even ends with a PhD on those ideas.
So are all your classes only around natural refrigerants?
Mine are, yes.
Okay. So are you seeing more students than like actually interested in this topic than before?
No, it's about the same. Okay. We have anywhere between 10 and 20 students every semester interested in refrigeration and air conditioning.
That's good. That's exactly what we need.
But one of the thing which really gets them into refrigeration and air conditioning is that I offer them to go for practical training in their 5th semester wherever they want in the world.
Oh wow!
I tell them take the map of the world and tell me where you want to go, and then I find the place for you.
Places like where? I mean, what's some of the most interesting
like
places?
South Africa, New Zealand, Australia, Jordan, Japan, Korea, China, Mexico, Canada, Argentina, Brazil. I mean, we haven't had any students on the moon yet, but
not yet.
Not yet, yeah.
Can go to the space station and see what, because I think there's CO2 as well that I read they use, not just ammonia. Certain processes, I
haven't been there, so I don't know.
Not yet. So I think we'll move to the Q&A session. There was a question about where they can get the textbook. Let me actually, that was going to be my last slide, but I mean, it is on the VDE web shop and they are shipping it worldwide. So I think that is the nice thing.
And we have already sold almost 200 copies out of 1,000 which were printed, and all the revenues from the editors and the authors are going to a foundation supporting our students.
No, it's good work all around, and it's not even that expensive. I think that was the part I was so surprised. Let me actually share that slide. Because I think that's the nice thing as well. You can also get bulk copies if you want it, and literally put your own branding on this and then give it out as company gifts or educating your staff. So it's there's a lot you can do. So I'm very excited about this. Like I said, I got my own copies recently, and I was very. It's one thing to look at the PDF for a year and then to finally hold it in your hand and it's an actual book. So I think that made me very happy. But I think, let's get into the Q&A session. I've got a few questions from my side for you as well. But of course, everyone else, feel free to share in the Q&A box if you wanted to. So I think you spoke a bit about the professor before you and things like that. But how did this project actually come about? Like what led to the German textbook being created, and how long did this process take? Like why did you think there was a need for this?
I mean, I knew that there's a need for training material for at least 25 years. When I started this consultancy for the governments to phase out CFCs in the late 1990s. I mean, from 2000, when was that, 2001 to 2005, we wrote the Islary handbook for the IR. So that was a 4-year process. It was quite time consuming. Wow. So I didn't feel like writing another book, but
a bit of a commitment.
I was approached by Bernd Hansemann, the publisher from VDE, and he asked me if I would like to write a book on natural refrigerants, and I said, oh, I can kind of get the right people to write it, but I will not write the entire book. And then, I asked a lot of different people and got the right authors for the individual chapters, like always people who have been working with their respective refrigerant for decades. And they all started writing. And then because there were so many authors, I think in the German edition, we have something like 14, 15 authors. When it came to the payment question, then I said, I mean, the revenue for each one of us will be so little. It's no compensation for all the time we spend. So how about just giving all this money as a donation to the students? That's what everyone agreed. And then we were lucky that we finished the German edition just a couple of days before the 80th birthday of Johannes Reichelt. That was
so special. I kind of imagine it as like, that movie Ocean's 11, and you're going and recruiting all the best people, to join the team and writing. Because I mean, if you look at the CVs of the people who wrote these chapters, it really is the top of the field of people who understand these topics practically, and like obviously on the theory side as well. So it's just amazing to finally have a collection of all this information, because we see a lot of training courses, but it's usually, I think, product specific and brand specific. So to have something that's completely, as far possible, neutral and coming from an academic point, I think there was definitely a gap for this. Because I think every time I'm at a conference or somewhere, people always use an excuse as they can't advance natural refrigerants faster because training is a barrier, or there will be too many accidents because people don't know how to use propane, and it's just excuse after excuse. So if we can actually tackle the training barrier, we really can just move the market forward. So I was very happy about this. So we said, I mean, from the English book has been very well received from what people we've spoken to, what we've seen on social media. But I think it's been how long has it been since the German book? Like 3 years now?
3 years, 3.
So what has the reception been thus far for the German textbook? How has it been received? What did people think of it? I mean, obviously it must be good if we're doing a second edition of it.
Yeah, they like it. So yeah, and the German versions they say they have maybe supplies for 1 year more, and then that's why we start working on the second edition now.
That's good. I mean, I think this is something I can see, like there's so many projects where, they're trying to go to developing countries to educate people, and there's just not training material. And this is a way to get a standardized resource that you can actually give to everyone. So I'm very happy about this. We got a question here in the Q&A from Phil Shepherd. It's asking, what is the typical leak rates for nat refs, and what impact do they have on heat pump efficiency? It's quite a bit broad for all natural refrigerants, but maybe.
I mean, heat pump efficiency, as I said, if you change from HFCs to hydrocarbon to propane, or if you go for high temperature heat pumps to isobutane, or even higher temperatures, you go to pentane, and typically the efficiency increases 10 to 15%.
And on the leak rates for natural refrigerants, is there a way to compare them to fluorinated gases? Or I suppose it depends from refrigerant to refrigerant. But
what do you mean?
Well, the question is like, what are typical leak rates for natural refrigerants? Which I think is a bit hard to answer for all refrigerants.
Yeah, and it depends on the application. I mean, ammonia systems, they are quite tight because ammonia stinks. So it's very easy. And actually, we right now have a project together with a company from Germany and a company from Switzerland, where we try to develop oil-free propane chillers and propane heat pumps. And as soon as they're oil-free, you can add odorants to the propane. Because we tried that in 1996, 97 in Denmark at the same stuff which you have in natural gas, which smells like rotten eggs. But the thing was that this additive ended in the oil. So the oil was stinking like really bad, but the refrigerant didn't smell afterwards. So the solution will be oil-free systems, and then oil-free systems will also increase the efficiency again. because if you go with micro-channel heat exchangers, or mini-channel heat exchangers, then the oil actually deteriorates the heat transfer coefficient on the inside. We made some measurements where, like, if you have, it's a rather high oil concentration, but you have like 5-6% of oil, you use 30-40% of heat transfer efficiency. So it's a good idea to run the system without oil. And if you have it without oil, then you can add some things which smell really bad.
A good solution. Oh, we got a nice, I have another question about a nice comment from Anders in the chat saying it's a very good book. And he realized that it's important to have a teacher that is really interested in thermodynamics when studying thermodynamics. Because when he studied the book they used in Denmark was also partly written by the teacher that he had. He said, keep up the good work, Kauffeld and the team. That's very true. I think thermodynamics can be very boring if you don't know who's
but you can make it interesting. That was the first thing when I joined the university in Karlsruhe. I asked where the local brewery is. And then I took the students to the brewery, because in the brewery you have all the thermodynamic processes. So you can explain it on site. And most students, they like beer. So you get all the students joining the class when you go to a brewery. I once taught in a microbrewery with 120 students.
That is an amazing way to get them interesting, because I've seen, so many people lose interest in this industry or not necessarily wanting to stay because they say it's a boring industry or it's not as attractive. But I think it's only as good as your teacher.
Years ago, I prepared a slide where you see like an airplane and you see a car and it says like, when I grow up, I want to design airplanes, I want to create cars, and I want to build cities. And then it says, have you ever heard the kid say, when I grow up, I want to design fridges? And that's the challenge we have in our industry. Like the best air conditioning system is a system you don't see and you don't hear.
That's the thing. We need a better PR person for the whole industry. Because I also had no idea what HVAC and R stood for. I've never thought of it as an industry. And so, I applied for a job 10 years ago and that was a requirement. So it's very much a hidden industry, but an industry that really impacts every single one of the sustainable development goals, which is...
We will start a new bachelor program called Green Technology Management. And we just made a video advertisement video for that. And I already had people in our industry saying, well, we need a video like on refrigeration air conditioning. And I asked this producer, and he is willing to do it. So now we are trying to collect some money, because it's a real professional team. They make the videos for the national broadcasting system in Germany. So this video we have for the new bachelor program was quite expensive. And the one we want to make for our industry will be more expensive, because we will go to different places. We'll take some videos at different companies explaining the different things and different universities. So it will be a universal video for the entire industry.
Amazing. And maybe maybe we can get some more students joining. Because I think that especially now the market's accelerating so fast. We really need as many skilled people as we can to just scale up fast.
Yeah, especially heat pumps. If people mean it, that they want to get away from Russian gas and oil, then we need heat pumps. We need a lot more heat pumps than what we have today.
We want to meet those decarbonization targets. There's no way we're going to get to that without heat pumps. Like we really...
It was a very good site visit I had with my students. That's a local ice skating rink. And it's using ammonia as refrigerant, which is nice. And it was designed that they have a heat recovery. So all the condenser heat and the heat from the oil cooler is going to a water loop. And the water loop heats the local swimming pool. But it's an outdoor swimming pool. And what they didn't think of is that the swimming pool is open from May to September. And the ice skating ring is open from October to March. So I was... That didn't help. I visited it once with my students, and then the swimming pool was 25 degrees and there was snow around it, and it was packed with birds enjoying the warm water. But nowadays they install the heat pump system to increase the temperature, and they are supplying heat to the other offices surrounding this ice skating rink. So it can be done.
Sounds a bit more smart.
It has to be done. But we definitely need people who understand heat pumps. So we are in the process of hiring a professor for heat pump technology.
That's good, because I mean, I think step one is for people to understand what a heat pump is. Because I think every time I speak to some, I mean, there's so many different kinds and so much confusion around it. So I think if we can get that step right, we already make a lot of progress.
Yeah.
I got a question here from Marek, just a quick one, asking if can R1270 be added to R290 to make it smell?
I don't know, maybe.
Having some new ideas for your classes.
We wanted to apply dinitrous oxide, laughing gas, because that has the almost the same vapor pressure curve as CO2. But where CO2 has a triple point at minus 56, it's for dinitrous oxide, it's minus 92. So you can go to lower temperatures. But unfortunately, dinitrous oxide can react quite strong with the lubrication oil in the refrigeration system. But when you add CO2, then you can make it safe. So we ended up having a 30% CO2, 70% dinitrous oxide mixture, and then we could go down to minus 78 in evaporation temperature, and the system worked safe even with lubrication oil.
You must have the most amazing laboratory where you can just try all these things and play around.
Yeah, and we invite school kids to our lab to show them, and then I always teach them how to spit fire and to play with liquid nitrogen, and especially the spitting fire, they all like the kids. In the beginning, they're afraid, but then when they see that one of the kids is doing it and is not blowing up, then all the others want to do it as well.
Well, it's a good way to get them interested while they're young, so they can say they dream of being astronauts or, refrigeration engineers, bit of a mix. So, I mean, where do you think we are today in terms of the state of natural refrigerant training, like globally? Is it at a satisfactory level? Are we where we need to be? Like, what do you think is the state currently?
We could be much further. The companies still working with not so nice technologies would stop their lobbying, but they have so high marketing budgets that
it's hard to compete with if you have the truth is hard to defend if you don't have that budget.
No.
I think policy obviously makes a big difference as well. The fact that Europe specifically, that it wasn't included natural refrigerants training in the last F-gas.
Yeah, you can just take the F-gas regulation for car air conditioners. In the beginning, the EU Commission wanted to set the GWP down to something like 5 or 10, but then there was one big American manufacturer. They didn't work on CO2 systems at all, so they would not have been able to sell their cars anymore in Europe because all the others, they had CO2 systems as a prototype on the road. So, and the EU Commission wanted to enforce CO2 systems in car air conditioners, but then this American company they just pulled 152A out of the shelf, and 152A has a GWP of 146, 148, and then the EU Commission said, okay, we don't want to kick this American company out, so we set the GWP threshold to 150, and that's why we have 150.
I'm so scared about all of these new refrigerants that come out. I think back in the day, you had like one or two options maximum for each application, but now every week there's something new, and like we don't really know what the consequence of everything is. Like we're getting so much like good peer-reviewed and like studies coming out saying that these refrigerants are doing actually a lot of damage. So I'm I mean, a chemical will always be a chemical. That's always been my stance.
You can just take the HFOs. I mean, they have a double bond between two carbon atoms, so they break down in the atmosphere within a day, 1 or 2 days, which is nice. But then they form trifluoridic acid, and this trifluoridic acid, if it would stay in the atmosphere, would also break down due to UV light within a month or two. But it will disappear from the atmosphere before that, and will accumulate in water bodies.
Water bodies.
And I mean, if you compare to 134A, 134A has a lifetime longer than 10 years. And so whatever you emit in Brussels or in Karlsruhe will not break down in Brussels or in Karlsruhe. It will break down in South Africa or in Australia. But with HFOs, they will break down locally. And there are some simulations from publication last year which show that in the area like Stuttgart, Munich, that Central Europe, we may have an increase of 250 times the TFA concentration due to all the car air conditioners, because the car air conditioners are, at least with gasoline cars where you have shaft seals, they are leaky. I mean, this may change when we go to electric cars and we get electric compressors and the systems get hermetic. But then if they're hermetic, then there's no reason not using propane.
Exactly.
Because, I mean, you drive to the drugstore and buy a spray can of hairspray, and it contains more propane than what your car air conditioner would contain.
That's the thing. People, I mean, everyone was complaining as well in the beginning, say it can't be done having like a hydrocarbon in domestic fridges. And now most fridges in the world have hydrocarbons in it. And it's a closed system and it's completely safe. And if you train people around it, we moved over. I think there's always an excuse.
And then Daniel Koegelenberg was part of this investigation in China for split air conditioners. In China, they had the Fire Research Institute, where they actually built the wall of a high-rise building, and they had like 3 or 4 stories, and then they were trying to ignite these single split air conditioning systems with propane, and their conclusion was it's 10 times safer than having isobutane in the fridge, in the kitchen.
Wow. I think there was that interesting study that Daniel Koegelenberg and them did for the LifeRun project as well, looking at actual leak rate, like leak sizes on hydrocarbons, because I think it's so massively exaggerated. There's going to be this leak and everything's going to explode. And if you actually look at the leaks out there in the world, it's never such a big leak as what is used in the study.
I was in 2002, November 2002, I had just started at the university in Karlsruhe. I was invited by the Chemical Manufacturer Association of South Korea and was in Seoul. And the evening before my presentation on hydrocarbons as refrigerants, I went out for dinner, and there was this small restaurant, and they had the outdoor unit of the air conditioning system on one side of the door and the gray gas cylinder on the other side. And then I thought, okay, this is an R22 system, very leaky, so they have to top it up all the time. But that was not the case. I mean, the gray cylinders were with gas for burning, and there were rubber hoses going to all the tables, and you had a little gas burner on your table, and you could prepare your own food. And there was no safety fuse built in those gas burners, so I could have just sat down, open the valve, order something to drink, leave the restaurant, and watch from 200-300 meters apart how this thing blows up. And then I took a picture of it and showed it to them the next evening and said, look at this split air conditioner. Could you imagine running this on propane? And they said, no way, that's too dangerous. And then I showed them the gas bottles, and they said, oh, this is safe, this is for cooking.
It's a matter of perception.
And they had 2 30-kilo cylinders connected to this restaurant.
That's so dangerous.
And the split air conditioning system would have had, I don't know, 300 or 400 grams.
Yeah, it's such a small charge for those systems. Yeah. So yeah, like you said, it's just big marketing budgets. It's a lot of fear mongering, even on the ammonia side. We've got a question from Joe on that, asking what is the future of ammonia? Here in the States, it seems as tough as though it has limited future due to its toxicity to human life.
Yeah, I mean, just take this comment of my professor in 1986, where he wrote like he liked the technical way of how I solved my homework problem, but he didn't like ammonia as the choice of refrigerant. He preferred R22. So, and I guess that's still the case.
I think, like you said as well, it's toxic to human life, but it has a built-in, like, you can smell it immediately, but long before it's toxic to you.
Yeah.
And I'm more worried about, like, the other refrigerants, like the R32s and the mildly flammable ones, because you will have no idea that's coming.
I mean, if this turns out to be true, what they predict, this major increase in trichlorotic acid, we will simply destroy the 1% of water which we have on our planet, which we can drink right away. I mean, we have a lot of water. That's why our planet is called the blue planet. 98% is undrinkable. It's just seawater, salt water. And 2% can be used as drinking water without treating it. And only 1% is accessible. The last 1% is in so low or deep depths that it's too expensive to take. And once we have TFA at a higher concentration, I mean, the only way to get rid of the TFA is use reverse osmosis, and that will make it very expensive and very energy intensive. So it's so stupid. I mean, it's known, but yet it's still. I mean, this initiative by the German, I think Dutch, Swedish, Norwegian government, and Danish as well, to try to get some legislation on HMOs in Europe. But I mean, it takes some time.
There's so many counter arguments, because like the one I keep hearing is that TFA is natural, it's always in water, but it's not in the fresh water. And that's exactly, and that's the most important thing. We have so little fresh water.
Yeah,
and I think
that's right.
Coming back to the question, the future of ammonia, I mean, low charge ammonia systems are like becoming more and more prevalent. So I think that also limits the risk a bit. But the thing with ammonia is you just, with everything else, you need to know what you're doing.
I mean, you can go as low as 20 grams per kilowatt.
It's phenomenal what you can do now with how low the charge is. I've got another question. Sorry.
Yeah. Go ahead, Ilana.
Alfredo's got two questions. He's asking, is per his knowledge, some are placing R1270 into propane compressors. What is your comment on that? So they're using propane compressors and putting 1270 into it.
And then put propene in. I don't know. I mean, I know a company who is using what are they using? I think R5 or 7 compressors, and they just use them with propane.
Wow.
I mean, they had to sign a piece of paper with the manufacturer that they will not come and complain, but I mean, they're doing it.
Sounds risky either way to use a different compressor than what it was designed for. I'm sure it's possible, but it's probably not recommended.
No, it's not recommended, but if you do the safety assessment, then you can work around it.
And another question as well, also from Alfredo, is like cascade systems above 40 kilowatt as per the F-gas, as stated, can address, R134A. Will ammonia be a possible solution here, or is it some kind of other natural refrigerant fluid?
Yeah, you could do ammonia. There are examples of small ammonia systems, but most of the compressors
above 40.
Yeah, the most of the compressors, they are open shaft compressors, and then that makes it a little bit more elaborate and more expensive. So I would, in that capacity range, I would go for propane. Propane in the upper stage, and then CO2 in the lower stage.
I think it's generally what we've been seeing is like, for the smaller installations, go the hydrocarbon route. And when you go to the larger systems and district heating and cooling, ammonia is just almost like a no-brainer. And especially if you have a system that large, you're going to have a dedicated person looking after it. So you don't have to worry about it being dangerous. And I mean, there's so many safety protocols you have to follow to get an ammonia system installed. That
was one of the reasons for using isobutane in household fridges, because going from R12, from CFC 12 to HFC 134A, it was almost the same swept volume in the compressors. But then when changing to isobutane, the compressors became bigger, the swept volume became bigger, which was good because due to the better insulation, the pistons were getting so little that it was difficult to manufacture them. So with isobutane, it was easier again. And then due to the lower pressures, they are also more quiet to operate than 134A fridges.
I think there's so much that's actually possible. And I think that's why training is so important and understanding all the solutions, because there isn't going to be one refrigerant that's the answer to everything. As a design engineer told me very early on, horses for courses. You need to take every application, every project on its own merits. But the thing is, there's a natural solution, refrigerant solution for every application now. I don't think we have an excuse to use fluorinated gases at all anymore. There's been so much research. There's market available products. You just need to educate yourself.
And the good thing is nowadays you have all the simulation software. Like when I studied that, we had to do all the calculations by hand. I mean, we had calculators, but still we had to look up the properties in steam tables and then type it into the pocket calculator and make all the calculations. But nowadays you just have computer programs and you can select the refrigerant and you can compare one by one, like 134A with isobutane or 4A with propane or 507A with propane, and then you get an indication of the answer right away.
Yeah, I mean, it's so advanced. You can even build like sustain energy efficiency models and things for years to come to test these systems. So it's
and people are even working on these life cycle climate performance models where you go all the way from digging up the copper somewhere from the earth and refining it and convert this into CO2 equivalent emissions.
That's phenomenal, because I think that's a lot of the issue with these low GWP HFOs and things. Like the manufacturing of these gases are actually producing such much more emissions. So the refrigerant itself looks low, but hard to get there. It was a different process.
It's 10 to 12 times more CO2 emissions for 1234 YF than for CO2 or for propane.
And then it's not even, like you said before, it breaks down so quickly in the atmosphere, yet we're measuring the GWP over 100 years, which makes absolutely no sense. And if you actually had to look at that impact and the time that it breaks down, it would be much, much worse. Than it wouldn't actually pass the legislation, it wouldn't. So it's getting
I mean, 134A is a good example, because the lifetime is so short. If you go from 100 years to 20 years, the GWP is almost double.
Yeah.
So,
and even on the HFOs.
Yeah.
So, I mean, we're running out of time fast. So I think that I just want to say thank you so much, Michael, for not just this session, all the hard work and actually getting this book out and trusting that it was going to be a worthy mission. I know it wasn't always easy, but I think it is for a good cause. It's going to do well.
I had good support from you, and from Bernd.
Bernd's been great. I mean, I also like a great thank you to Bernd from VDE. Yeah. He's been an amazing publisher on this project. We couldn't have done it without him. Mm-hmm. So yeah, I mean, we will be sharing. The link will be live, and we will be sharing the presentation. So please go check out the web shop. I mean, the copies are not expensive, so it's very, very accessible for everyone. So with that, thank you very much, and enjoy the rest of your sessions.